Okay, hello everyone. My name is Filip, as already said. I'm the CEO and co-founder of Epsilon Data Science. Before founding Epsilon, I worked for Microsoft in California. And my background is mostly technical. I finished, I've got double degree in applied mathematics and computer science. But mostly I work with business people. I do not code anymore. I only think what's possible and what's not. We work with corporate clients. Most of them are international, from Western Europe, from States. I cannot mention every company and organization we work with, but some of them are Fortune 500 companies, and these are pretty advanced topics that we solve. As you see, these are not only finance companies because we are industry agnostic. We mostly focus on the right process, and even though I'm going to have the core to address finance and insurance today, I think that this is still very important to know that my opinions may vary because of different industries we work with as well. So as we see machine learning and the data science process, there are four core ingredients to the process, and we address all of them. First and foremost is data, and this is probably the most important ingredient, which we sometimes forget because it's obvious. And so through different our projects we've accomplished, this is reoccurring fact that increasing the quality of the data is the simplest method to deliver better accuracy. And you can do that in various ways. I think that a lot of companies think that they already have the data problem solved because they already implemented the data warehouse or the data lake and some other form of database. But the crucial thing is the data quality. And to get there, you can think of many different solutions, but one that we found that's working in practice is to implement similar process to the source code. So when programmers work on a program, they implement continuous integration and they implement tests. So whenever you change the source code, you run the tests automatically. And we do the same with data. Whenever we get a new data set from our client, or if they gather data on a daily basis, we run tests and validate the quality of the data on the daily basis. Through that, you can get a report saying that okay, all checked. You have a green status, and you feel that you're safe, and that this is not going to destroy your quality or accuracy in any way. The second part of the data thing is the data acquisition part. So nowadays you can think of tons of different sources of data. You can get data from IoT. So for example, in insurance industry, you can gather the data from the mobile of the drivers to give them a better offer, insurance offer in this case. But the same goes with credit scoring, I believe. So if you have a source of data that you can use, that's probably worth consideration and creating hypotheses. And this is going to be a second part that I'm going to mention further. But the whole credit scoring thing is very similar to research as all the data science work itself. So going through acquisition part, IoT is just one example, but of course, social media and many companies already thinking about that. You can actually get new features on your own by maybe sending a little computation to that device that your client is using, and through that you can validate what performance of the computation you get on the device itself. So you can see if your client is using a high-end product or a low-end product. You can, what else you can? Of course, all the classic methods are still valid, and these are the most important ones, like history of their credit and history of their transactions and so on. So all the time frames, and you also have a feature engineering thing where you try to construct new features from the existing data. Yeah, I probably have a few more ideas, but later on we can, maybe during the panel thing. Models. I think that one important, like we already get from Vladimir very good explanation of the pros and cons of going linear or with gradient boosting trees up to deep learning stuff. But the most crucial thing is that deep learning is costful, and you have to hire very specialized team with deep background of the topic, with good understanding of the consequences, and linear models are much cheaper and can be delivered faster. So if you can get linear model rolling in a month, maybe it's better to have something rolling in a month instead of working on something for several months and seeing the results only in the future. The third part, same as data, not with enough of focus nowadays, is the reproducible research thing. And what I mean by reproducible research is that when you have a model, let's say you have a data scientist that implemented a gradient boosting tree or linear model, you have to make sure that in 1 month or even in several months, like 6 months, you can get exactly the same results that you get today. And there are many ways to do that, but this is something very important to understand, that getting the process right and making sure that you can get the same results and also show to the business people that, okay, we are moving further, we make progress, because see, 1 month we were like maybe 1 or 2% worse, and now we are better, and we get better on a weekly basis. This is very important. And the last but not least is the interface part. Here, this can be an API. So if you use the forecast or prediction on the mobile, of course you can use API. But the more interesting for Upsilon stuff is using dashboards. And I don't mean dashboards like Power BI or Tableau, but smart dashboards that also gather data from the people that are using the dashboard. So if you have an expert that works with the dashboard, we can actually also track their behavior to get their behavior into the model itself later on and improve accuracy. So here's a list of some potential ideas that I can think of in finance. Of course, this is pretty fuzzy, so you can mix and match. You can, for example, if you have a chatbot and you are a credit company, then probably you can do some sentiment analysis to create features for credit scoring. So I think that this is not something very strict, but there are tons of ideas, and you can actually reuse some work from other industries as well. So you can, for example, take maybe some image recognition to the finance industry as well, if it improves something that it's worth trying. But let's define success for successful credit scoring project within your company or other finance projects. I think, like in my opinion, the 3 main points are to get a business advantage, because we see that technology is the key to success in the future, in a decade. And to get there, we need to be faster, we need to automate, use less resources, or get better accuracy. And what is also very important, we need to keep that advantage. So, as I said, this is not something that can be done once. This model that you are going to implement within your company needs to live as well. So you need to keep track of the accuracy you have, and if it's crucial, then you need to improve as well. Through gathering new data sources, through improving the model, through experiments. To get constant improvements, and this is also a valid point for implementing the project itself. I think that one thing that proved to be unsuccessful and complete disaster for a data science project is a fixed scope. So you have a project that says that you have only 8 weeks to implement the stuff. This is doable if the only thing that you need to implement is some kind of model. But the crucial thing is the accuracy itself, and you cannot guarantee any accuracy before you validate the model itself. So it absolutely doesn't make sense. If the work is to implement, the data science platform or the dashboard, this is something easier to estimate. It's still software, so we all know it's pretty hard because software projects are complicated and there are some unknowns. But for data science stuff and machine learning stuff, this is extremely difficult because you get to one point and then you have an idea, oh, maybe we need to consider another feature, or maybe we can get a new data source. So it's very important to redefine the scope of the project and do it as fast as possible. And you can get there through Scrum, but I believe that there are some other ways. For us, Scrum proved to be very successful. And iterations are also important because they give you a rhythm of work, and you validate hypotheses. And validating hypothesis is a good way of thinking about that. Just a few last, yeah. So it's good to keep iterations. Regarding accuracy, I've already mentioned data governance. Code review is another thing that we took from software engineering, where you have data scientists read their code to make sure that there are there are non logical mistakes in the model itself. So you improve quality if you have double check. And reproducible research I already described. This is an example of Domino Data Lab. This is a startup from San Francisco, and it's just one example of data science platform where you get kind of continuous integration for machine learning stuff. So you get a statistical results of the data model, and everything is kept in a Docker containers, so you can rerun the model after a week, after a month, and so on. But there are others as well. And one last thing that I want to mention is about dashboards. I think that it's fairly important to see that they also help with regulations, as already seen in a previous presentation. But and this is just one example of the dashboard we've built. It's for reducing churn. So in the middle you get the predictions of what to offer to your client, and you can do that during the phone call, and through that you reduce the churn and you upsell at the same time. 3 last points, what to keep in mind and sum up: fixed scope, fixed price. These are things that might stop your progress and are pretty dangerous. Getting off track. So if you lose track of your current accuracy, if you lose track of your current quality of the data, and yeah, data quality as the most important way to improve your models.